Okay. So I'm Noam from Microsoft. For those who don't know me, I work in Excel with performance for several years now. And let's see. Okay. So I just want to cover a bunch of web performance APIs and scenarios that we use to optimize performance in Excel, and also highlight some opportunities and some pain points that I think we can improve. Just heads up, this gonna quickly cover a lot of different areas and topics. So if you have any questions, just take a note so we can follow up later and get easy to lose track when going through so many topics. So Excel is an SPA, a very complex application with many scenarios, a lot of dependencies, many scenarios, user flows, and we feel performance is a very important area, and we keep investing it, learning, finding ways to improve the user experience in terms of performance. I would like to think about performance in three major areas or scenarios. One is the page load experience. Second is the interaction responsiveness, similar to INP, although we're currently not using INP. I'll expand on that later. Async UI latency, when you interact and then sometimes later see a response, and animation smoothness, for example, when you scroll interaction in the UI. So page load experience, it's a large area. I'm not going to cover all the aspects of page load experience. I'm going to focus on one main bottleneck, which is resource loading. Specifically, JavaScript resource loading is a big bottleneck for us, and I understand for many other apps. And in general, there are three ways to address resource loading problems. You can download them sooner, download them faster, or run them sooner or run them faster. And each one of them has their own challenges and bottlenecks, and you can use different APIs to address them. For downloading sooner, we use link preload. You can use it for using a link tag in the header, or link tag in the head, or you can use link headers. And we've used it in the header HTTP headers, and we did see some gains on top of using the link tag. We can use early hints. It's not something we already implemented, but we're experimenting with it, and we think it might give us even additional improvement on downloading things even earlier, before even the first response officially arrives. The second approach, download faster. In general, there are many ways of downloading faster, but the best way is to make the file closer to the client. And by that, I mean increasing the local cache hit rate. There are different ways to achieve that. One of the main things we're doing is doing aggressive prefetching of the next versions. That means we try to identify which versions are going to be loaded in the future and prefetch them to the client. And so the next time the client load, we get a cache hit. The second approach is reducing the file size. There are different techniques to do that related to bundling, minifiers. I can share more if there's interest. Currently, we are experimenting with compression dictionary transport as a way to downloading only the difference file between two versions that are loaded. And I have a slide on that later. The last one is running sooner and faster. So after the JavaScript was loaded, how soon can we actually run it and make sure it does useful work for us? We're extensively using JS self-profiling API. We started at boot time, capture call stacks that are running, and try to identify what are the bottlenecks and then optimize. We use also LOAF API at boot time, and then we try to identify if there are any bottlenecks that are not JavaScript related, like compile, rendering areas, and so on. For measuring the main API we're using is resource timing. We just track all the resource downloads and aggregate them and do a complex analysis on top of that. Second area, interaction responsiveness. Essentially, it's what we usually talk about when we say responsiveness, from the time the user interacts until the first response is displayed. We're using an event timing API. We capture the performance entry, correlate them with the specific interaction that happens that we know of when we added the event listener. And then we create a metric based on the average responsive action rate per all the sessions that we collect. And we consider responsive anything that's below 100 milliseconds. The next challenge is determining bottlenecks. So when we have unresponsive interactions that are higher than 100 milliseconds, the challenge is to know what's causing them to be longer, essentially why the main thread is blocking for too long. In many cases, it's JavaScript, and we heavily use a JavaScript self-profiling API. We aggregate it, correlate it with the event timing entries, and create tools that allow us to drill down and understand for each interaction specifically what was the bottleneck, what JavaScript was running and blocking the main thread. We're also experimenting with LOAF, correlated to event timing entries, and so we have better understanding of, again, things that are not necessarily JavaScript. LOAF is also useful for general high-level aggregations of different areas. Third area, async out latency. I'm just gonna give a quick example of what I mean by that. So if this is the grid in Excel, when the user right-clicks on a different area on the grid, that's going to be the interaction time. We expect on the immediately second frame to show the selection that has changed. And then the reaction to right-click interaction is showing a context menu. But it's an expensive interaction. It could take a lot of time to create a context menu, maybe load actually additional JavaScript or configurations, and then we can render it later on. So that's what we consider async UI latency. The first interaction is that's what we consider as responsiveness, and the end-to-end is what we consider as UI latency. So how do we measure it? We're using element timing API. In the absence of current solution for generic tracking of containers that we discussed yesterday, we use a mock measurement. We create a DOM element that is empty, so it can be tracked using element time API. We add it to the DOM just before we want to show the UI, correlate some performance entries with the original interaction so we can measure the end-to-end latency and duration, and then track percentiles, the interaction duration at different percentiles, and analyze it. And then again, for understanding bottlenecks, we're using different tools and techniques. The last area I'll cover is animation smoothness, particularly scroll, but it also used for other continuous interactions like dragging things and so on. The challenge here is creating a user metric that reliably, or I guess in a way that really represents what the user feels around smoothness. We tried to use the FPS. That didn't work out too well. Right now we're using essentially taking measurements while the user is scrolling and running a rough loop during that time, and then trying to find how many animations framed we had in 100 millisecond chunks, and based on that we create some kind of metric. The challenge for identifying performance issue, again, for that, we're using LOF as well. We sometimes see that while the user scrolls, there's some lag or jank. Sometimes we see missing content. We were able to use LOF and notice that it's correlated relatively reasonably. And therefore, we use that as one indication. We also use just Self-Profiler API to find the root cause, like I explained earlier around responsiveness. We correlate the scroll chunks with specific call stacks, so we could understand the exact root cause. For general API usage that are not falling particularly on one of the other performance areas that I covered earlier, scheduling async task, it's mostly using set timeout throughout the application, either directly calling set timeout on the window object, or indirectly through different layers of libraries and wrappers that eventually would call set timeout. We did start adopting prioritized task scheduling, the post-task API, so we can use different priorities for interactions that are either more urgent or less urgent, and we want to make sure the UI stay more interactive. For new code, we actually recommend engineers to use the post-task API. Since not all platforms support this API, we actually have a polyfill that if the API exists, calls it directly. If it doesn't exist, it tries to imitate the behavior using set timeout. There are some challenges with the polyfill that we had to address, but in general, that works pretty fine. Reporting API, we use the NEL for tracking errors, and that a lot of time gives us a good signal of what's going on, especially when there is a regression. It's always good to look there and see if there's anything that changed in terms of network errors. And we use crash reports, which helps not necessarily us as web developers, but it does help us to provide the signals to the platform guys. The last part, some opportunities or pain points, some areas we could think can be improved. On compression dictionary transport, so mentioned earlier, we experiment with pre-generated delta compression files. We offline during build time generate diff files between the JavaScript that we release and the JavaScript that currently we expect available cached on the client. There's some challenges with the current shape of the API. First challenge is metrics, measuring. Currently, the resource timing API, which is the API we use to track resources, does not give us any indication that a delta file was used when the response comes back. So with compression dictionary, the idea is you send a GET request, receive a file. Now the file is cached on the browser, and we have a dictionary for that file. So the next time we get the second version, we expect the delta compressed file to arrive. But it's not always the case. Sometimes we don't have that data file because we didn't generate it for whatever reason. And it's hard to measure when we had a success and when we didn't have a success. Currently, we're using heuristics, using the transfer size. We know that the delta, if we hit a delta file, we know it should be much smaller than the expected size. It's hard to maintain, but it's useful to already see the huge benefit of using compression dictionary transport, because you can download much smaller files. We see the download time, the fetch time, and also initialization time all goes down when we get the file hit. Another thing that feels like missing, and it'd be good to learn more about that. Once the delta file arrives, there could be some time and overhead to apply the diff file in order to get the full file from it. There is no way to measure it using any existing API. Another challenge is achieve minimal delta compressions and generate a lot of files. And there's some other race conditions that we have to deal with. Scroll interaction start time, that's something that we discussed in the past in this group. How do we measure the latency from the interaction that initiates a scroll until the scroll actually starts? Currently, the only indication we get is the on-scroll event, which can happen sometimes much later than the actual interaction. And since we don't want to keep monitoring the UI all the time, we only activate our monitoring on the first on-scroll, and that's basically mean we have a blind spot. We don't know what is the real scroll experience, especially when the user starts. And we have some ideas of what can be done there, but nothing concrete we actually did not. Another challenge that we have related to scroll is sometimes when we scroll, we see areas of the area that we scroll that appears white for a brief period. And some investigations show that it can be related to long animation frames. Sometimes there's a long animation frame that blocks the main thread, and therefore the content when it renders doesn't show, but that's not always the case. Sometimes we don't have long animation frame and we still see these white areas. And when we profile it, we can see strong correlation with partially presented frames. And there's no current way to measure and understand when you have this situation. And we don't really know what the magnitude of this phenomenon is. Is it like a widespread or a corner case? But we do know when users are complaining that they see this, they have this experience sometimes, and we cannot explain it with just JavaScript on the main thread. Worker performance metric, this is something that recently we started looking into, and other groups at Microsoft also have interest in this area. There are few metrics that helps us to understand the situation on the web worker. We have multiple web workers that execute a bunch of more expensive tasks, offload from the main thread. And it's hard to tell when the worker is busy, and when you send it a request and you don't give a response in a reasonable time, it's hard to understand what's going on, why you don't get that request fast enough. And we don't know, maybe it's contention, maybe the tasks on the worker are taking a lot of time. Maybe it's task prioritization, that just the task completes, but then it takes time until it gets its turn on the main thread when it returns. We're thinking of potentially if there's a way to send tasks and provide priority, that would also help improving web worker performance. We understand that sometimes actually people are discouraged from using web worker because they don't understand why the response doesn't come fast enough. So all the benefit of offloading from the main thread sometimes goes away with some latency that is hard to explain. Paint Worklet, we actually experimented with Paint Worklet and found that it could provide some solutions to some complex scenarios around performance. The main challenge with Paint Worklet is that, first of all, if it runs some JavaScript, and if you cannot understand when the JavaScript fails, there's no way to interact with the worklet. It runs in a completely different environment from the main thread. You got just specified using CSS. So if we cannot detect failures and it's a critical functionality, we're going to be hesitant of using it fully in production. Also, some understanding of what is the performance of a Paint Worklet, some timing measurements. It's basically a black box to us. We can just tell it to run, but we don't know anything about what happened when it ran. And HTTP transfer encoding. We use multiple chunks during boot when the initial page loads, and it's not just that we load the head and then the rest. We load the head and then we load additional chunk for maybe the first things that needs to run in the beginning, and then we load another chunk and maybe another chunk until we got all the necessary data that we need to load the application. We found that using this technique is very, very useful for performance because it reduces a round trip, right? You just the connection just waits and content arrives. It's almost like a push concept. But there's no accurate way to measure when those chunks arrive besides adding JavaScript tags and capturing timestamps. But those timestamps can be skewed by other JavaScript that may be running at that time. And when we test it locally, we see there is a gap. So we don't trust the JavaScript timestamp. And if there was a way to know that, it would have been helpful on understanding and optimize things further. And that was it. And for questions.
I didn't do this as a presentation, also because we discussed this in a WebPerf working group call, and I don't want to repeat this as a presentation. I actually wanted to resolve on things in this conversation, if possible. Even if we change resolutions after, let's like be concrete about this. But I'll start with the overview of what we're trying to solve here. We're actually trying to solve a couple of things that came up that I thought were the same thing, but might be a bit separate. So this is a LOAF issue 3, so it's one of the first issues that came about when we released LOAF, where people were complaining about the constraint that LOAF only exposes script entry points, meaning whatever you pass to the platform, set timeouts, foo, or add event listener, or some promise resolver, or just a script element, etc., or import. And people were complaining that sometimes it's not granular enough. It just if you're in React world, for example, you'll just get this like big React callback thing that doesn't help you. And the other complaint, which is somewhat separate, is they're blaming us for our wrappers complaint. It's especially true for libraries or run providers or that are wrapping everything in the world, and then it looks like anything slow is the fault of the messenger. It's the blame the messenger problem, right? So this was there was a separate issue which we thought was actually related to this because it was about tracking. I think we thought that the solution is related, even if the problems are somewhat separate, which is this one. Open, yeah. So this is an issue in user timing, and it's about adding more information to user timing for the lab, for dev tools or for tracing or for Lighthouse, giving it more color, literally or not literally. It's like coloring tracks in the timeline based on user timing, or giving it all kinds of info that can go into other tools, into other lab tools, etc. So if I go to what this is about, so I saw it as like people want more information on what's going on. People want to trace things, more info. And when we started working on it, we thought, why can't people just use user timing everywhere? Like it already exists. And then the thing is that user timing is an infinite buffer. And if you start filling an infinite buffer, without some method of erasing it or emptying it, then all kind of things happen, or I don't know. So not all the things. We want to trace things, but not all the things, right? So which things do we want to trace? We thought that probably what people want to trace is more granular causes or diagnostics for jank, for long animation frames, or for long events. This seemed like the main use case for what we call conditional tracing. Trace more things, but not all the things. Right? Now, the other thing we saw, and this came as a result of the working group conversation that I couldn't attend about this, is that finding out the problem and creating attribution/blame are issues that are somewhat different. When it comes to attribution or blame, we need to be very exact about what we report. And we can't just let people do everything in user time. It has to be very specific to what caused the low-off, because libraries, etc., rely on this. So with two problems, there are two-ish solutions. One is conditional tracing and diagnostics. So we fill user timing thing like fill it with a buffer. The buffer is associated with a particular performance observer. It's not just a global of performance. So, and the buffer gets emptied when we know that it didn't cause jank. So if the buffer is associated with the low-off and the low-off was the animation frame ended, there were nothing in the buffer, or then all good, like we just discard it. This is the magic part of this. And also we represent this buffer as an object. And this object can be used as additional info for lab tools when there is a lab, like can give it color, can give it a full JSON object of whatever it is you want, can give it things that only specific tools understand. So talking about this object as is the center point between this conditional tracing, between tracing, jank entries like LOAF and lab tools. See if I can share this. Yeah, I can. That really well. Okay, let's do it like this. Okay, so thinking of this as an object, this is my current API proposal. I wouldn't call it a strawman. I actually want to resolve. So call it a performance track, because it's kind of like a track in a timeline. You can mark and measure in it the same way you do user timing. It's not necessarily my favorite API, but it's consistent with what we have in user timing. So I kind of wanted to keep that. Now, if I have a low-off observer, I do this attach track. I basically associate this track with this observer, which means that this observer is what's going to empty this track when there's nothing to report. I used an object also instead of like a name string because of global name spacing. Like there's lots of developer issues with global name spacing, especially around user timing, where you start having to invent all kind of like weird strings just so that some other library doesn't catch them. When you have an object, it's just a natural namespace. So you attach the track to observer, and when the observer fires, you have the entry now has tracks, or it has sub entries that are those marking measures that were not emptied and are actually contribute to this particular loss. This and I know there's some confusion about this. This is the other part of it in the previous working group discussion. The idea is the console namespace is a way to speak with the lab, really, with lab tools. It's a way to speak with dev tools or with Lighthouse or with anything. So the idea is that not that this would be there in production, but rather that when you run your app or whatever in lab tools, you can add additional information to the track you created, and let DevTools know about it. So this is not production code, but rather lab code in the page. So this is the performance observer. I'll go quickly to the bind. I think they kind of together they provide the whole solution. Yeah, the bind issue is that Loft only provides script entry points, right? What we're suggesting here is to allow the author to provide their own entry point, to say it's kind of like the black boxing in DevTools, where you say this part is not something I care about, or I also care about this internal part and not just about this external part. So thinking of something like this, you'd have a monitored function and you call performance.bind. And now this function you got back is something you can call. So as a wrapper library, you can wrap whatever it is you're calling with this, and it will call performance.now internally in the beginning and the end, and it will treat it like an entry point for the purpose of LOAF. I think what I need to figure out with this is that this does not include promise microtasks that are queued inside the function. And this is a limitation of this API, and might need to think about that, or like wrap a few things separately, etc. Anyway, this is about it. Conditional tracing to discuss.
They're happy to take like clarification questions in the middle, but if we want to hold everything till the end.
We'll till the end if we could.
Yeah.
Yep. All right. Hey, welcome back from weirdness. I'm Scott. Give an update on scheduling APIs. So the last time I presented was last year at TPAC. So I figured we'd update kind of since then, but go back to the beginning. I think there's some folks that might not know all of this stuff. So primarily this year, we've been focused on scheduler.yield. I was kind of looking back in some slides, and like first time we proposed this was back in 2019 at the WebPerf face-to-face, and got a lot of interest then, but it kind of got shelved for a while. But with the recent focus on responsiveness and IMP being a kind of a driving force to revisit this, and with the goal of kind of providing a really simple API that developers could use for breaking up tasks, improving responsiveness. So we spent a lot of time with origin trial and design and getting this shipped in Chrome in M129. So we'll talk a little bit about what that design looks like. Also spent some time when we were working with TAG on the spec review. They requested, we kind of had post task, which I'll talk about, some other APIs, a bunch of proposals, and various stages of kind of completeness. And they suggested we do like a big picture explainer that they could also review to give folks an idea of how all this fits together. So worked on that, went through tag review. So I linked to those. You can take a read through, but they're supportive of, the directions we're going in and some of the things that we're thinking about. And in this talk, I'll talk, majority about, like, since it's kind of updates about like where we landed on scheduler.yield, how it all works, just to refresh folks. And then just talk about some like really nascent ideas around extensions that maybe we can do with yield, and just kind of top of mind things that we're thinking about. All right, so I figured we could start kind of at the beginning, like, why are we doing this? Like, why scheduling? And so I work a lot in scheduling in Chrome, and during periods of thread congestion, this is when scheduling really matters. Like, this is the way I think of it, at least. Like, the web is bursty. There's loading, softnads, input handling, interactivity, like interactive sites run JavaScript. Main thread gets busy to the degree that we can move stuff around, break things up. We have an opportunity to improve performance. And the things that we're focused on mainly right now, main thread performance, but the two main tools we have: breaking up work and prioritization. And just to call out that this is like, separate from reduction of work or offloading to workers. Like, that's the other way you can improve performance, and like, you don't have to do one or the other. You can do both. Like, like, make the main thread less busy is also good. But what we're focused on is for things that have to run on the main thread, how can we, optimize that? In these strategies, like, we use them in the browser everywhere. I'm sure other browsers use this as well, not just even on the render, but like in the browser thread, like, we chunk up work and we prioritize it in very similar ways that we do on the render, and that sites could do. So main goal has been kind of improving responsiveness lately, and both the APIs that we've shipped so far lend themselves to that. And the reason is simple: long tasks, they block input handling. Like, y'all work on IMP, which for me has been amazing to see that work progress, because we use it internally as like something that we can optimize. Like, finally having responsiveness has been really, like, kind of key to that work. But like, kind of anywhere in the input like stream, like, you have a long task, it's going to block the input from even being processed. If you have a long task in the frame, that can block presentation. So it's kind of what we're targeting with responsiveness. And then also, it's going to help with user perceived latency. Earlier in a talk from Noam, he mentioned this. They have a concept, async something latency, UI latency, and like, I call this like before user perceived latency. I don't know if it has a well-defined like name for that, but like, that's the other thing that we don't measure as well. But sites can use this to, by breaking up and prioritizing work, making sure, the stuff that should be on the critical path runs early, and get stuff off the critical path. So it's kind of the goals of what we're looking at here. And I want to spend a little time just as background. I realize that I like so deep in this stuff, and like, other people probably don't think about like this part of the spec like all that often. But so just kind of like what the UAs do for scheduling, or at least I'll speak to what like Chrome does, but also what like the spec allows us to do. So there's a lot of things that run asynchronous in the browser. They get scheduled through like the queue a task HTML algorithm. And UAs have flexibility here. Like, every time they do queue a task, it has a task source associated with it. There's a whole bunch of these. We keep adding new ones like all the time. Timers have their own network, DOM manipulation, there's locks, WebGL, like on and on and on. There's all these different things. And like, all the spec guarantees that if the HTML spec is that things associated with the same task source are run in like queue order, FIFO order. So that's what the guarantee, and it's up to the ordering between sources is not guaranteed. So that's where the browser has flexibility to do scheduling, and it's up to the UA to map the task sources to a task queue, or any number of task queues. You can have a perfectly compliant implementation with one task queue, or you could have one task queue per task source and do whatever you want. So this is kind of evolved over time, but I thought it was just, I don't know, this is just to be clear, this is Chromium's implementation. This is not going to be the same in every web browser, but like, this is one way that you can do this. This has evolved since I've been kind of working on scheduling. We kind of create new lanes when we see new opportunities sometimes, and do this kind of orchestration. I'll explain all the arrows on the right in a minute, but like input, discrete input, like clicks, typing, that runs out of an input task queue that we have, and we always run that at the highest priority. Like it's essential for optimizing IMP. Render, we have like this new kind of newer concept. This is maybe a little bit, we kind of subdivided some task sources into like, certain resource types we want to load. Like if they're available, like we can handle the completion of them and we can render, we want to load them first, because otherwise we might get layout shift. It also can improve like LCP, for example, by like a frame, something like that. So we have a certain like kind of a lane carved out for these that we call render blocking network resources. We have another lane carved out for like urgent messages between the browser and the render process. So like for navigation, we want to make sure that's as speedy as possible. And then we kind of get into the bulk of all of these different task sources. So the way that users can typically schedule tasks either through like set timeout or post message, all these things we kind of bundle together with like that whole other long list of things, because we don't really know like what is the optimal thing to do here. All of this different script, it just kind of runs, as if it's one queue. And then below that, very bottom, we have idle periods that sometimes run, sometimes don't in the background, that kind of thing. Like, and they can only run when there's nothing else there. So rendering in Chrome is super special. We treat it as another task, and its priority is variable. Depending on kind of what the user's doing, we try to optimize, and we always try to ensure that it doesn't get starved for the most part. So we will kind of raise its priority. This is kind of a different approach that some folks take, or some browsers may take, by just like varying the frame rate. We kind of just make these decisions about like what priorities should we have rendering, and then that fluctuates. That's kind of the status quo before like any of these the APIs that had been working on. All right, so the first one that we worked on some years ago was scheduler.postTask. This is the kind of the beginnings of the prioritized task scheduling. And we thought of this as a tool for improving responsiveness and latency, with the idea that you could, okay, if you have developer has a task, it's this like maybe long synchronous chunk, like that's bad for responsiveness. If you have function boundaries, like maybe like you could with set timeout, but like you have these function boundaries that you may be able to break this task up and schedule the individual pieces. And then it gives you some control over how those pieces are scheduled. It's also like a modern async API. It returns a promise, cancelable using abort signal, task signal. Tasks are controllable with a task controller, which is a subclass of abort controller, so you get both abort and priority. Dynamic prioritization. And then we've talked about this a lot in the past year, but for folks that haven't seen API shape, it's on the screen here. It returns a promise, so you can await it. It resolves the return promise with the result of the callback. So if it is an async function, it'll return a promise, in which case you get promise chaining, and like it'll wait for the whole thing to be done. And then you can specify the priority. We have 3 priorities: user blocking, user visible background. You could also pass a signal to do cancellation and dynamic reprioritization. So to kind of illustrate, now again, this is Chromium's implementation. The spec as we've written it defines the ordering between the tasks that, like the task sources that we created here, like these priorities. So like user blocking always runs before user visible, always runs before background. But where you slot them in, because there's so much flexibility already, like we give flexibility to UAs to like schedule this how they kind of see fit, with a strong hint in the spec now that says like this is kind of how one way to do it, which is like how we're doing it, where user visible is roughly equivalent to like a set timeout or post message, which, and I keep bringing up post message because a lot of sites will use that as a better version of set timeout, because it doesn't have like if you schedule a bunch of them recursively, you don't hit this like 4 millisecond minimum timeout value. So people started using that, and that's kind of spread. But anyways, this is where we slotted them in. So user visible gets kind of lumped in with everything else. So if you just use the default priority, which is user visible, then you just get like maybe a more ergonomic way to schedule tasks and break things up. But you can also deprioritize at background. In our implementation, we treat that as lower than these other task sources. Or you can do user blocking. So you may want to, again, like you could just run this all synchronously, in which case you're not responsive, or you could break it up with user blocking priority, limit kind of what might run in between, and still remain responsive, which is a net win for performing. Okay, and nothing much has changed since the last time I presented this last year, so we shipped this a while ago back in M94, no changes there. Usage has been ticking up, so we were at 1.25% last year, up to 5.4%.
Wow.
It's a big increase. A lot of it, I think, was lately, like people are using this as a yield polyfill before we had yield, because you can get some of the benefits of it by using user blocking priority. Like you get this nice advantage of, yes, I want to break this up, but I don't want everything else to run, which we'll talk about here in a minute. So that's starting to come down a little bit now as yield's coming up. But I think, and I'll show, I think the APIs work nicely together, and there's, depending on how your app is architected, you may use one over the other. Okay, scheduler.yield. So as I said, this was it's kind of focused this year, and hopefully that what I was just kind of describing will help kind of understand how this works a little bit better. So yeah, main goal again is we want to provide the problem is we need to break up long tasks because it's critical for responsiveness. As mentioned, one approach is to maybe schedule tasks on function boundaries. And another approach, which is simpler works in a lot of cases, especially if you already have async tasks, is you want to just yield and continue in the current task. Like you don't need to pass a callback to like start over here. Like you just want to yield, like let the high priority stuff run and then resume. So that's kind of the pattern that we're going here with scheduler.yield. As said, the main goals really facilitate responsiveness, enable the UA to stay responsive to input, and whatever other high priority work the scheduler might see fit. We want to mitigate some issues that I'll talk about in a couple slides with there's some performance issues that come along with yielding if you're just using like the existing solutions. And then we want it to be easy to use, have good defaults so that developers can just use this, like sprinkle it in and like, break things up and hopefully see performance wins. So this is the bigger change since last time. Like last time I presented this, it had very similar arguments to PostTask, but like we, at least as far as what we've shipped, we'll see if we need to add this back in, but like this is it now. Like we simplified to the point where like we have like you can just await schedule.yield, assuming it's an async task or async function. You do some work, you insert a yield point, and it resumes afterwards. You don't, we took away the specifying how the continuation runs, and part of that's just to simplify things and have these good defaults, and then can reevaluate if we need it. But like if you need to schedule things at the various priorities, like we have PostTask, like that can work. And on the next slide, I'll show how these kind of work together. Oh, actually, no. The next slide, we'll talk. Never mind. I'll talk about the prioritized continuation. So I mentioned that there's some problems with existing mechanisms, and like this is something that we heard a lot from developers. Is like, yes, I know I need to yield. Like I know I have long tasks, but I don't want to break them up because we're hesitant to give up the thread, because if we do, then we're not going to get it back until everything else runs. And to a large degree, that's true with things like set timeout. So this is like my old slides from that per face-to-face. Without yielding, like, let's say you have a long task that's running, and during that long task, input comes in. So user clicks, but there's a 1 second long task running, and that's going to block it from starting. So it has to wait. Like we can't do anything JavaScript, we can't preempt it. So input and the subsequent frame, what we're measuring for INP, can't come until after. With yielding, if you're breaking things up at like, regular points, if you have long tasks, then if you're using set timeout, so in this example, in the middle track here, the continuation, let's say it's scheduled with set timeout. So if there was already in the queue, then it goes to the end of the queue, right? Because there was already one that was ready. So the chunk of work happens, then maybe the UA can process input and rendering. But a previously scheduled task gets in the way. So what you end up doing is the latency of that one task is stretched out over this whole section here. And what we do with yield is this yield continuation pattern where you have this chunk, but continuations are considered to be higher priority. So you call yield, UA is like, aha, I have input, we can do that, and we're going to render a frame that unblocks, you know, the initial response, and then the continuation run. So everything kind of just like, everything just gets pushed out a little bit rather than something getting kind of an unfair advantage. All right. Then the other feature of this API is yield itself inherits the priority and signal if it's used with one of the two APIs that has priority, either implicit or with post task. So by default, it just, you know, it schedules a continuation with this little bit of priority boost. I'll show on the next slide kind of how that slots into this system. But the use case that we have in mind here is like you have like, so let's say a background task, like it's a long task, it's a long background task. You like, let's say this is maybe you could try, but you have this example of a bunch of steps. For each step, we're going to run it, and then we're going to await yield. So the question is then what happens? Like when it resumes, how do we treat that continuation? So what we did was for post task that has a priority, we use that to make the decision for scheduling the continuation. So it gets a boost, but only a boost above background. So we treat it as kind of like, you know, conceptually, this is one task. It's one async task that's just broken into pieces, but it's all connected. So if the post task scheduled it with a signal that's abortable, then we can abort on those. We can stop it early as well. Yeah, so that's kind of how inheritance works. We'll talk about this a little bit more tomorrow because there's a lot of overlap here with task attribution and soft navigations and stuff we were talking about earlier. But we use a similar mechanism. So even if there's a waits in between, when like we thread that through. So the invariant here is that like the priority after an await or after a promise continuation, like the scheduler retains that. It knows what it like. It's the same internally before or after as it is before. So in this case, there is another wait, but like if that step was asynchronous and you did a wait, this would still work. The continuations would still run at background +1. So this also works for request settle callback. It will schedule the task. It'll fit it into this new prioritization model, but you do a request settle callback and you yield, then it's not going to go up to like that elevated priority. It's still going to consider it a lower priority task. Yeah, and how we do it. So now our diagram is getting bigger and bigger, but kind of we've created these kind of like pairs. So we had user blocking. Now we have user blocking continuation. We had user visible, and now we have user visible continuation just above that. We have background and background continuation, and they slot like right in between the other ones. So the guarantees that are provided are that, again, those are well ordered just like they are for post task. So there's a ordering on that set of tasks. User blocking always before user blocking continuation is more important than user blocking, more important user visible continuation, and so on. But again, it's up to UA, like kind of where you draw the line or how you want to integrate this with like other task sources. What we're doing in Chrome is that we're saying that user visible continuation, because of those problems that developers are facing, we want to have that elevated priority. So we slot that in above, you know, and if it's just you're taking something synchronous and breaking it up, like that's still like a win, even if it's going to block those other things, because it was going to block those other things regardless. All right, and that's yield, and that's where things are at. As I mentioned, we did simplify the API by removing the parameters, but we can revisit that if needed. We weren't exactly sure how we wanted, like how that should work with inheritance. So rather than like, you know, rather than overthink it or do something that might not be needed, we just figured we'd start with the simplest thing and like let's go from there. It wasn't we did origin trial this with a bunch of partners, and like it didn't come up as a thing that was necessarily needed. this is shipping in Chrome in M129, which is stable. I think it went to stable about a week ago, and we saw usage. I haven't checked exactly like where usage is all coming from, but like we're up to 1.6% like of page loads already, which thought was pretty cool. So yeah, thanks for all the conversations over the last 5 years on this, and it's exciting to see that ship. Yeah. All right. If that was rambly, this might be more rambly. So here are a bunch of ideas that these are just use cases we're exploring. Some of these are in that big picture explainer that I had mentioned, and the one of them that I'm going to talk next isn't. This is just something that has come up kind of like, in the wake of yield, like there's another use case around analytics that we thought might be interesting in exploring. So like some questions to think about as I'm talking this, like, yeah, are these use cases I think we should explore here? Are they good fit with like yield? Like, what do folks think of that? Like, we're not sold at all on how to expose these things. Like, these are a lot of open questions. So this is really just kind of a brainstormy like second half of this. So, yeah, while back, I know there's this pattern, idle until urgent. I don't know if that comes up in this group, but this is a particular use case of idle till urgent that maybe folks here are familiar with. There's a potential trade-off between responsiveness and like not losing data. So you may want to yield, like, like in a click handler, like you want to yield. It's good for responsiveness, but the continuation is not guaranteed to run. So like if the site's about to navigate, like you click on a link and you yield, navigation happens, like you might lose data if you yield. So yeah, that's the problem. And we're kind of like, we were talking internally, like, oh yeah, like what's the story for this? Like, I think like you can mostly just solve this with racing tasks and event handlers. Maybe not 100%. And I'd love to hear from the group, like, pain points around this. It's tricky. Like, I think visibility change is the recommended way to do this, where like you could schedule a low priority task or a high priority task or whatever, or you just yield, but also you would need like a visibility change listener either per like event or like one that checks to see are there tasks remaining that need to run. But if there are any kind of use cases where you're collecting data in the background, like the visibility change isn't going to fire, like if you're unloading the page, so then you probably also want to hook into page hide as well. So this is more complicated. And then if you are doing it like per listener, like you really need to make sure you unload those or unregister those. Otherwise you have like a whole buildup of page hide and like visibility change listeners that are going to run on navigation, which isn't good. So I think, yeah, we could probably make a library for this. But without having like a good built-in primitive, like maybe there's a risk of folks in this situation not yielding, which is going to lead to poor INP. So maybe it is something that we should address in the platform. With the cleanup I said and multiple listeners, like it could be tricky to get right. I took a stab at like making a polyfill here. I think maybe this is like right-ish. Like you can use, like if you're using post task, you could use a signal, and what's nice, like add event listener takes a signal, so you could kind of abort whatever's remaining like when you do it. But I don't know, it's a little gnarly. And maybe, yeah, I don't know, maybe okay, yeah, these are obviously placeholder names, but please run before hide. Like maybe you could pass an option to yield and await that. So you await yield, or it could be a post task, and you say, yeah, I want to do this, but like just make sure it runs, before hide or unload or like whatever it would be called. That's like just kind of one shape that could work here, and it's just a lot simpler. And then we have a built-in solution to tell people like, yeah, if you're worried about like losing data, like this will, unless it's navigating away, this is just going to get scheduled as a regular task. But like on those cases where that is happening, we're going to make sure it runs. An open question about like, yeah, is it just a polyfill on like existing methods, or would we need something else? Don't necessarily want to be extending, navigation, but like if it's just a way to do this existing thing, like maybe that's not terrible. You still want to use with like fetch later because like it's, maybe you're unloading or something like that. That's just one idea. Another idea is like the same thing, like please run before hide, but like on events. So like maybe you could just attach that to like the event handler. Now, that, yeah, it saves you a little bit of step because you don't have to do that yield right away. But if we're comparing things like, you know, you lose a little bit of flexibility, I think, with the event approach. Like if you need to do anything ahead of time, then that approach might not work. So like, it also, we don't quite have async events yet, but plug Michael's doing a breakout session tomorrow on like, can we do async event listeners and what would that look like? So, you know, maybe there's some like sugar that like later if we were to pursue a solution here. So yeah, and maybe with this flag, like, you know, I don't know. And I don't know if this is the right you know, if this is the right shape, like you could add a parameter to yield, because like it really is the thing, you are yielding, you just want like some guarantee around that continuation. But maybe that's not the right API shape. Maybe event listeners aren't either. Maybe a new API would be a thing to do here. But the main question, like, is this even worth, you know, is this worth exploring? Is this worth building into the platform? Love to hear like, some folks' thoughts on that. But it's just something that comes up a lot internally from requests from partners. So we know that there is like demand for this. And it's like, what do we want the story to be around this? And kind of a follow-up question, like this is one example of idle until urgent, but there may be other use cases here. So I'd like to hear if there's, you know, other use cases. Do we need like some way to flush tasks? Like if you have a task controller, like I don't want to get in a situation where people are doing this manually, where like you've scheduled a bunch of tasks in the browser and oh, like also we're tracking all of those callbacks in user space, like userland as well, and we're going to flush those like on sync. Like, do we need some way to like flush the remaining tasks in, you know, I'm always wary of like doing anything that might like take like too much time and like be janky. So like, that's why I do like the like, you know, we have this one use case, maybe this handles most things, but like, I don't know, something to think about. Like maybe there is room for this type of API. All right. So the next topic, scheduling and rendering. So there's a couple things, and I think we floated one of these last year. It's something that comes up a bunch. I think this came up, and I don't know if the person who sent the email this week, but I think this came up in the WebPerf like emailing list recently. So please wait for render. So the idea is like you want to wait, you want to yield, but you also want to guarantee that like whatever DOM mutations were done are displayed before resuming. So example would be a click, like a really short UI update. Like most of the time, like rendering like may be ready, but like if it's really quick, you know, you get out of the way and yield, and then you do heavier processing. There could be a race between rendering and that frame, and like you really, the whole point of yielding is that you want to display that initial response for like responsiveness reasons. So that's one that's one use case. I know this does come up a lot where people just want a way to do this double RAF, like they want to update DOM and then get out of the way, make sure it's displayed, and then like continue and do more mutations or continue on. So like double RAF has been one way historically that we've solved it. People are always kind of looking for something simpler. You could do RAF plus scheduler.yield, like that seems fine too. But yeah, is there room for like an API here? It's worth noting that like single RAF isn't sufficient. So like developers do need to like learn that. Like you can't just like bounce it into a RAF, because if you do that, then that like is going to block whatever you do in the RAF handler comes before paint and everything. So like that's actually blocking presentation of that frame. So, you know, with that said, like having a nice primitive there, you know, it could be helpful. We're also like, you know, there is a question I've been thinking about, like, do we need to do this? Is this something that's just that the UA could do? Do we know that like, okay, you've yielded, the DOM is dirty, like I may want, like, especially if it's for responsiveness, we may want to just, if we know the frame is like minutes, like not run tasks there and like wait for that frame to happen. So we're kind of experimenting with that in parallel here. So we had a proposal for this that folks seemed interested in for sure, which was scheduler.render. But there's a long thread that you could look at 95 where weren't exactly happy with the name. There's some inconsistencies in that with some in the other Yuli APIs. So we're looking into, yeah, how exactly should we expose this? So another option here, because it is so similar to wait, is like whatever this option becomes, again, this is a placeholder, but like please wait for render, like pass that to yield, like add an option to yield such that yeah, if that's passed, then like if that set in rendering is needed, then it's going to resolve in a new task, but after rendering. So it won't block. If rendering isn't needed, then we could just basically fall back to schedule.yield because there's no point in waiting. That's one of the use cases we're interested in making some progress on if we could solve the name issue. And then the last one that I wanted to chat about, which we kind of had coupled with this earlier one, is this idea of please render now. And the thing here, so like, let's say that a site knows, this is a use case, like the site knows that above the fold content has been loaded, like they finished streaming above the load content. They want it displayed ASAP, right? Because like that is for them like the point at which like our load is complete. There isn't a way to indicate this to the UA. Like there's a lot of complicated parser heuristics and really no signal that says like, you know, now is a good time to like do this. So we've had some folks that are interested in this type of thing. You know, so that's kind of the question. And again, we haven't really explored this too deeply. So interested to hear people's thoughts here, but like, could we tell the UA like, hey, this is like the opportune time to render, like we'd want to like control rendering that way. So originally we were thinking about maybe putting these things together, right? Like scheduler.render like seems like almost a bit of an imperative, like we would like you to render, and like saying that, okay, if this is called, then like that also indicates that rendering is high priority, but I don't know, coupling these just seems bad to me. The use cases are different and like it might lead to like over boosting and it's not really what you want everywhere. So yeah, kind of at the beginning here, but just thinking about like if we were to do something like this, or at least experiment to see, like I would love to experiment to see if this does really improve things for sites. How would we expose this? Like request animation frame is close, at least in name, but it's not really the same thing, right? Like you're requesting a frame to do rendering work, but like here you actually want to flush rendering before you move on. Could add a parameter to that maybe, but yeah, I don't know. Is JS even the right fit at all? Like, or could we add something declarative to elements to like indicate this? So yeah, just some early thoughts. Interested to get folks' feedback, and it looks like that's all I have. So yeah, just a reminder of kind of what I covered here. So thoughts or questions on any of this appreciated. Any other scheduling pain points? There's some stuff, like I said, we didn't cover here. We are thinking about like extending post-task priorities into some other APIs. Mentioned it a little bit earlier. And also we another plug, we have a joint session Friday afternoon with a WebPerfWG. We could talk about like next steps for you know, one thing to think about, like, you know, here, like, what are the next steps for scheduling in the working group? So. Good.
All right. Thanks everybody for sticking around this late. For those that are interested, so the title of this is RUM Pain Points 2024 and the RUM Community Group. And maybe you're thinking, wait a second, didn't we talk about RUM pain points a couple of years ago? Well, yes, in 2021, we had a similarly titled session where we kind of solicited some ideas from other people, other RUM providers, and had a good chat about it. And if I'm still around in 2027, I promise to do this again. And if I'm still around 2030, maybe we'll keep on doing this indefinitely every 3 years. We'll see. But again, so in 2021, what's the TLDR of it? So when we talked about this 3 years ago, we had a bunch of thoughts for the people that kind of participated in making the stack around the things that were important to us, just to kind of talk as a group with a shared voice. We talked about trying to minimize observer effect. I think in particular that was around better, more efficient asynchronous loading of our JavaScript so that it wouldn't block onload, but still be able to be loaded with a decent priority. We talked about the desire to have better attribution for the APIs that we're building. In particular, like long tasks was kind of a pain point, but obviously we've had some improvements on the horizon from that. We talked about wanting to get better understandings of single page apps. A lot of our customers have SPAs and a lot of the APIs are not geared towards SPAs. A lot of discussions around network monitoring, so visibility into cross-origin iframes, being able to observe things better, more efficiently, the types of data you would want from resource timing, things like content type, content encoding, etc. And a little bit about the reporting API. Since then, in the last few years, I think we've actually made some pretty good progress on a lot of the things that the RUM community finds helpful. So, we've seen a lot of good improvements from things like send beacon and fetch later. I think that those are very positive for people that want to send data. We've seen a lot of the APIs being built have a lot better attribution. Long animation frames, event timing comes to mind a lot. All the core vitals have, rather good supporting data on like what the thing was that was measured, the LCP URL or the layout shift element that shifted, et cetera. That helps customers not only track a metric, but also know what to fix. We've seen some, decent support for SPAs. Soft navigation heuristics is being experimented with, resetting things like LCP, something that our customers have been asking for quite a bit to track. And then a lot of improvements to resource timing. We have progress on response codes, early hint initiator types, incomplete requests, content types. So anyway, I think very positively from the kind of things that we can do with RUM now, they've been moving in a very good direction. So just to kind of step back a moment a little bit, we've been getting together with a few other RUM providers, and we've been just talking about things that are important to us. And I'll talk more about that later in the conversation about how that kind of goes towards the RUM community group, but thinking through some of the things that are important for RUM and just kind of, we talk about these often when we're talking about API shape and stuff like that, but some of the things that we think are important to us, not necessarily sorted in this list, but just kind of brain dump of things. So obviously we want to avoid the observer effect. We, want to do everything that we can with minimal overhead, right? There's not zero overhead, but as minimal as possible. We don't want to affect the things that we're measuring. Don't add CPU, do things as efficiently as possible. We want to work well with others. My team is a third-party RUM library. We want to be able to be on the same page as other third-party RUM libraries, which happens often, or first-party libraries that are doing similar things. So things like global buffers that can be reset can be somewhat painful because whatever RUM libraries on the page may decide to do that, and then the other libraries, get the side effects of that. Everyone having an equal right to data, ideally, without affecting each other when possible. We like to observe rather than having to wrap or hook or patch. Example of this is like being able to measure the initiating of network requests. Our product has to patch XHR and fetch so that we can know when things get started if we wanted to. It'd be much nicer if there was just an observer we can listen to in that case, especially when there's other third-party libraries that are doing the same thing. We get into loops and other bad issues all the time. Like it's all the time. Not everybody codes defensively, and nothing's perfect when you're in another website with many other RUM libraries or many other libraries, for that example. RUM, either first party or third party, is not always the first thing on the page. We may be loading later. We may be bundled with application code. We may be loaded asynchronously. We may be intentionally loaded late, like post load sometimes. So ideally, if we can look back, see what happened before we arrived. There's a trade-off there, of course, with you don't necessarily want to hold on to everything for indefinitely if nothing's going to listen to it, but it does make our RUM job a lot easier if we don't have to force ourselves to be in the head or, as early as possible, because there's potential SEO challenges with that, or people having concerns with us being late and blocking rendering, even if we're doing things asynchronously. So as late as possible is ideal. Ideally, RUM can be integrated with just a script tag, whether that's a script source or a kind of loader snippet that loads things asynchronously. The opposite would be requiring HTTP headers to turn things on. Just from a deployment point of view, especially for a third-party RUM provider, inserting a script tag into an HTML somewhere for our customers is way easier than asking them to change their headers, which is like a, whoa, don't be talking about headers to me, man, kind of a response. So yeah, sometimes in the past we've talked about using a header to turn on a feature or like a buffer or something, and possible, but it can be kind of more of a pain for deployments. Attribution. Attribution is so important. Who cares if a number has changed if they don't know how to fix it, right? So anything that we can do to back up what changed or why that number was measured that way is very important. And SPA support. We have a lot of customers that are using SPAs. They all want to be first-class citizens in their measurements, and we've had to jump through a lot of hoops to measure what we can, and we can't measure all the things that they want, especially with core vitals and stuff like that being important. So given all those kind of principles for us, again, that was kind of a rough list of things I put together. Other RUM providers probably have other opinions as well, but we tried to get some review of that. Some of the challenges that RUM consumers and providers and developers may see is obviously inconsistencies between browsers. I think we've talked about a few of them this week, and things like response start as a good example, right? It can lead to a lot of questions from people looking at data. It can lead us to taking time of having to figure out, well, is this because the browser is performing different or just measuring things different, and loses customer trust if we're seeing things differently between browsers, or like the definition of what we're measuring is different between browsers. A lot of RUM providers are generally not also browser developers. So while we're smart in a different way than the browser developers, and we don't necessarily have the capabilities of building new features into browsers as the browser teams do themselves. And those teams have to balance many different priorities, and RUM providers are not the top priority all the time, as much as we try. So, we're still missing, I think, some things that some of us in the RUM community would really like. But, there's always a prioritization question, and not everything we want can be there. So, we have like in this slide deck, a little later, and 3 years ago, we kind of had a list of issues of things that are important to us. And yeah, again, I think a lot of them we made progress, but some of them we can't. So we're trying to figure out as a group, like, how do we push some of these forward? Do we do it ourselves? Should we as a group, pay for some other contractors to help implement if we can get agreement on what we want? So in that, we started looking into, well, some of us were meeting just offline, and we started looking into, should we formalize kind of what we're trying to do here? So there's community groups as a type of organization within the W3C. It's a open forum without fees, and you just need 5 people to support the group to get it started. So we decided to form the RUM community group. Submitted this the other day. Anyone is welcome to join. We do have to get support from 5 individuals in order for it to be formalized. The goal of the group is, just a forum for discussing RUM related topics. No membership in the W3C is required, no fees. So we're hoping to get a little more diversity of people besides those of us in the room. Audience would be, developers, sites using RUM, third-party RUM providers. And what we would be trying to do is to talk and discuss, maybe do some research reports, maybe, work on a principles document, or have opinions on what we would like to see within the broader community, maybe bring some of those opinions to the working group. Maybe work on test cases for things that are tough, but specifically, we will not be developing specs. Like, that's not part of the goal of the community group. This other discussion forum that we're currently in may be useful for that. So some of the names that down below have had some involvement in these discussions, and obviously we're looking for more if other people are interested. So trying to figure out what next steps are, classic propose a group, question, profit. Obviously that's not it. We need to wait for the W3C to review the proposal. I saw that it already made it to the blog thing. So I think you can actually go there if you click on that link, and I don't know exactly how to get to that link, but if you click on there, you can vote it in support. We need 5 or more votes in support for it to be formalized. And then the future would be we'd start meeting regularly-ish to talk, really. So wanted to pitch that for anybody here that's interested, or if you have any teams or people that you think would be a good fit for that.
Would you be willing to go back 2 slides to the list of interested parties? Oh, maybe that's 3 slides back.
Yep.
Thank you.
And it certainly is not an exclusive list. It's just a list of people that, when we were reaching out to earlier, I had some people interested in talking, and we've been talking for a couple months now. Yeah. Okay, so given that, that's one kind of just notification for the group. If you're interested, either try to find the link on the W3C website or contact me after, and I'll try to find the link for you. We did take a poll just amongst that same list of people to like, here's some things that we've all kind of been talking about over the last few years. You know, everybody vote and get your vote in. So summarizing this list into kind of like the top-ish priorities. Take this as a very, very rough cut. And again, here's a list of things, right? A list of things doesn't do anything, but just to kind of bring it back to this group for things that some people in the RUM community think would be important to maybe look into, again, like next year or so.
The first one there, which seems to have the most
Yes,
codes. I think
by one.
behavior there seemed to different.
Can we wait until
Yes.
then, please? Thank you. Appreciate it. So yeah, let me just, and this is the last slide as well. So let me just talk to these very at a high level, and then we can dive into any questions if people want to talk about it more. Okay, so this was just a poll of, you know, less than a dozen people. First one, non-blocking async script loading. And what I mean by this is that, you know, we have things like async and defer. They do affect the onload event, and we would like to have a way to load our JavaScript that does not affect the onload event. Onload event, obviously not being the most important thing in the world, but it does affect other browser indicators of loading, obviously. So we, you know, different people deal with this in different ways. Today for Mpulse Boomerang, we suggest this Kilbright minified script that uses preload in modern browsers and iframe loading in older browsers, just to avoid to get an asynchronous loading over JavaScript and avoid blocking the onload event. And that's the only way that we know how to do it. So if we could have a little attribute on a script tag that does that for us instead, that would be nice. Maybe, or some other thing there. We've been talking about server timing standards, and you know, not that necessarily is the exact thing that this group would be focused on, but we're kind of interested in. We read server timing. Server timing is great, especially around CDNs. Maybe putting out a collaborative document on the shape that we would like people to talk about, cache hits or edge time or origin time or whatever we want to talk about. A bunch of things around measuring kind of pre-connect effectiveness, knowing if it was active and if it's useful, if it's helpful. I don't remember what all the RT issues are for number 4. There's 3 different issues I linked there, but better support for initiator. I think a lot of this is around kind of building the resource tree, if you will, this JavaScript fetch this JavaScript, which fetched this image. It'd be nice to kind of know what happened there, and you can do a lot of interesting things around critical path and you know, suggesting to RUM customers what the best thing to improve may be, if you will, if we can do some of that. A lot of just small fields for resource timing, you know, content encoding. We talked about that earlier today in the context of compression dictionaries and knowing if they're active or not. There's some issues with stripping authentication. It's called just the basic URL off.
Basic off.
Yeah, from URLs, just because that can be a customer, you know, security and privacy issue. Getting the HTTP method, because that can matter for some content, of course. There's a lot of little things like that, and you know, we've talked about those Obviously, it being issues in the working group themselves, but they would help. Around LCP, trying to fix what happens with pop-ups and how that affects LCP. Element timing, container timing, certainly I think is important. We talked a lot about why this week as well. That's my last slide. Happy to chat about any of these. If anybody is interested, I'm happy to just let y'all mull over this. And I think we're hoping the RUM community group will pick up and maybe come up with even, more to the point list of things that we either think we could try to continue the conversation on, or convince some of the people in this room that it would be fun and exciting to implement some of these, or maybe not. Then we'll try to figure out if we can do it ourselves. But yeah, that's all I got for the presentation.